Delivery.
Thanks. Is this lettuce? Where'd you get this? It's the dead of winter. What do you mean? Lettuce doesn't grow around this time of year, you know? You haven't heard? There's a phenomenon called photoperiodism. Photo meaning light, and period meaning increments of time. This is the phenomenon that controls the flowering of plants, enabling us to control when they flower, producing lettuce in the wintertime. There are 3 types of plants involved in photoperiodism: short day, long day, and day neutral plants. Let's start with short day and long day. Despite its name, these plants actually flower depending on the amount of darkness you give them rather than light. Think of it like this. If this was the timeline for your day, for a short day plant, this would be the amount of light you get and the rest would be night. So in essence, a short day plant is in fact a long night plant. The same goes for long day plants. If this was the amount of day you got, the rest would be darkness, meaning that a long day plant is essentially a short night plant, like our beloved lettuce. Well, day neutral plants follows its name. It doesn't matter how much darkness versus light you give it, it will flower, like tomatoes. Plants possess a built-in 24-hour body clock called circadian rhythms. Circadian rhythms is what causes the different times for flowering in different plants. Now you're probably wondering, if they all run on the same 24-hour system, why is it that they have different times of darkness to do the same thing? Well, think of it like this. If you set one clock at 3 o'clock and another at 9 o'clock and you let them both run for 24 hours, they would have run the same amount of time, but they would have ended up in different numerical positions. The same concept can be applied to the different times of flowering for different plants. It turns out that plants react most to red wavelengths of light. They have pigments called phytochromes that act as photoreceptors or light-detecting tools that help a plant know when it's dark and when it's light. There are 2 types of phytochromes, one PR and the other PFR. PR absorbs all red wavelengths of light, and PFR absorbs all far red waves of light. So what happens is when PR absorbs red, it isomerizes or changes into PFR. And when PFR absorbs far red, it changes back to PR. Then when light shows up, containing both red and far red, will hit the PR, which changes into PFR, and then PFR will immediately change back to PR, establishing this equilibrium. So in essence, how a plant tells when it's dark and when it's light is depending on how much of those phytochromes are available. Equipped with this knowledge, we can now grow any type of plant, no matter what time of day or what time of year it is outside.